Hello everyone, myself Vinay Kumar M. I am actually pursuing PhD in physics. So if you want to learn physics, chemistry and mathematics starting from 8th standard till 12th standard, then please do subscribe to my YouTube channel. So in this particular channel, I was actually teaching 8th standard mathematics subject. So in that I was actually teaching the chapter 5, that is squares and square roots. I have done 3 parts on this particular chapter. Now this is actually the 4th and final part of this squares and square roots chapter. So if you want to understand squares and square roots of 8th standard mathematics, then please do go through all 4 parts which has been uploaded in this particular YouTube channel. So if you want to find the related videos, then please go to the playlist section of my YouTube channel, and from there you can easily find out 8th standard maths, 8th standard science. In future it will be 9th standard science, 9th standard maths. Like that I will be going on creating playlists in my YouTube channel. So this particular chapter is the 5th chapter of 8th standard mathematics. So it will be in the 8th maths playlist. In my last video, I was actually explaining what is square roots. So if you want to find square root of a particular square number, then you will use certain methods. Like I have taught one method, that is repeated subtraction, and the second method which I taught in that particular third part video is prime factorization method. So in this particular video, I'll be teaching the division method to find square roots, and I'll be solving the exercise 5.4. So this division method is actually the method 3 which is actually discussed in this particular chapter. So method 3 is division method. So in division method, you should at least remember the square, like perfect square numbers starting from 1 till 100. Because remembering perfect square numbers starting from 1 till 100 is very easy. I think you can remember that. So the first perfect square is 1, second is 4, third is 9, next is 16, next it is 25, next it is 36. So you can just go on doing 1 square, 2 square, 3 square, 4 square, like that. So at 9 square you will get 81, and at 10 square you will get 100. So that means 1 to 10 you just have an idea of square of that particular numbers, like starting from 1 till 10. So you'll get perfect squares in between 1 to 100. Because here in division method, we will be making group of 2 numbers. 2-digit numbers means it will be within the span of 1 to 100. So if you remember the perfect square, then it will be easy. So I'll just explain how to do this division method by taking an example. So you just remember that you should remember some perfect squares starting from 1 till 100. So that is actually 1 square, 2 square, 3 square, 4 square, 5 square till 10 square. So let me take one example to understand division method properly. So one example is, let us take a perfect square 729. So if I want to find square root of this particular number, then I can easily follow this division method. Because if you do prime factorization, it will take little bit more time than this particular division method. And if you are actually doing repeated subtraction, then that will consume your lot of time, because in repeated subtraction you will go on subtracting odd numbers starting from 1. So there it is like too much time consuming methods. So let's find out square root of 729 using division method. Just take 729 and start grouping 2 numbers from units place. You should always remember, from units place you should go on grouping 2 digits. So first you just group this 2 9. So starting from 9 you just count 2 digits. So it will be 2 9. So this is one particular group, and there is no pair for 7 to group up. So 7 will be one group. So here 2 9 will be one group, 7 will be one group. Let's say I had like 11,235. So if I give this particular number, then you can group these two, and this one will be one group. So you got 3 groups here. So like this you should go on grouping first. So now forget about the second groups, whatever it is there here. Like forget about this 29. You just concentrate on this first group which is there, and see through that which is the nearest lowest perfect square for that particular number. So the nearest perfect square to 7 is 9, but 9 is not lower number than 7. So the nearest perfect square which is less than 7 is 4, because 4 is a perfect square, 9 is a perfect square. But here 9 is higher than 7. So you cannot take 9. So you should actually take 4, which is actually a perfect square which is near to 7 and it is less than 7. So let us take 4. So to take 4, you should actually do 2 into 2. So 2 2s are 4. That means 2 square is actually giving you the perfect square 4. So that 4 you will be writing below this 7 and you will actually subtract this. So when you subtract 4 from 7, you will get 3 and you just take this 9 down like this, 329. So now you just double the quotient whatever it is there here. So when you double the quotient which is there here, so that will be 2 into 2. So that is 4. So you just take 4 here and see through that after putting which number into which number you will be getting 329. So let's say I'll put 1. So starting from 1 till 9 you can try going on multiplying so that you will get to know which particular number is actually giving you 329. So I'll show how to do that. So now you have 4. So just go on multiplying 1. Like let's take 1 and multiply this 41 with 1. So what will be the answer? 41. So you are not getting 329. So 1 you cannot put in this particular position. So I am actually seeing which number can be put in this particular position. So this position is blank. So let us take 2 in this particular position. If you take 2 here, then you should add 2 here also. So if you do that, then it will be 42 into 2. So what is 42 into 2? It is 84. So this is also not equal to 329. So you should get this particular 329 as your number. Next you can do 43 into 3. So here if you do 43 into 3, you will get 129. So this number is also not matching with this particular 329. So like this, if you go on performing at 7. So when you put 7, it will become 47 into 7. So 47 into 7 will be equal to 7 7s are 49, 4 carries, 7 4s are 28. 28 plus 4, 32. So 32. So now you are getting 329. That means in this empty place I should put 7 and in this quotient I should put 7. So 47 into 7 will be 329. So now you are getting 0. So that shows this particular 27 is the square root of 729. Like this, you can also find the square root of decimals as well. So let us take another example, 7.64. Here you will follow the same method which we have followed for normal whole number, but here you just put the point wherever it is there in the quotient as well, so that your square root of this particular number will also contain that decimal point which should be there. So let us go on solving this using the same division method. So 17.64 you just write like that. Here also, starting from this place, you go on making 2 digits group. So again you should actually start from your right hand side only. So 64 will be one group, 17 will be one group. So you can just go on solving this particular number and find out the square root and put decimals wherever it is required. Like if you are actually taking 64, then take decimal point in the quotient as well. So I'll just show that how to do. So which is the nearest perfect square to 17? That is actually 16. And 16 is less than 17 as well. So what is the square root of 16? 4. That means 4 into 4 will give you 16. So when you subtract 16 from 17, you will get 1. You just take this second group down as it is. So 164. Now, because you are taking the digits which are there after this particular decimal point, so in the quotient also you should put decimal point when you take this down. So you should actually put decimal point and then take this 64. So whatever things you have learnt in division in your primary school, the same thing we are applying here, but here we are doing in a different fashion to get the square root of a particular number. So now you have got 164 as your number, after getting 164 as your number, you should double the quotient whatever it is there. So what is the quotient we have got here? 4. So what is the double of 4? 2 into 4. So 2 into 4 is 8. So you just take 8 over here, and whenever you take a number like after doubling this quotient, you should actually put one more number after this particular number, and you should multiply the same number in this quotient as well, so that you will get 164 as your answer when you do that, or number which is near to 164. Because if this particular number is not a perfect square like 17.64, if it is not giving a perfect square root, or let's say when we did 729, if it is not giving, it is not a perfect square, then you will not get that particular number approaching to 0. Then you should take nearer number to that particular number whichever you got. Now you have got 164. So let's see we will get the number equal to 164 or not. If you are not getting that particular number, you should stick on to the number which is less than 164, which is closer to 164. Should not go above 164. It is the same division what you will be doing to find quotient of a particular division. So now let us take 1 in that position. So 81 into 1 will be 81. That means in this particular position, if I put 81 and here if I put 1, that means 81. So here I am taking 1 and multiplying that these two numbers with 1. So here I am getting 81, which is not equal to 164. Now if I put 2, then it will be 164. That means now I should put 82 here. So when you put 82 here, so 82 into 2 will be 164. So now I can put 2 in this particular position and 2 in this particular position. So 82 into 2 will be 164. So what is 164 minus 164? That is 0. That means there is no need of doing further division here. It is remainder is approaching to 0. So whatever numerator value we have got, that is 4.2, is the square root of 17.64. So the square root, this is the symbol of square root, 17.64. So square root of 17.64 is 4.2. So using this division method, you can also find the square root of non-perfect squares, and you can also find square root of fractions. You can also find square root of decimals. So after learning this division method, we have certain exercise problems in exercise 5.4 based on this particular division method. So I'll just solve that particular exercise. Please observe. Coming to the first question in this particular exercise 5.4, you have 10 questions in this particular first question. So, you have 12 questions in this particular first question. So I cannot solve all 12 questions and show you how to do it. I'll solve 3 questions out of these 12 questions. So remaining questions, similarly, you can do using division method. So here they have given a certain set of perfect square numbers. So you should go on finding square roots of this particular number. So I'll solve 3 problems, out of which the first problem is 2304. So I can go on using division method and find square root of this particular number. So I'll group from units place starting from right hand side. So 04 will be one group, 23 will be the another group. Which is the nearest perfect square for 23? 25 is actually nearest perfect square to 23. But 25 is greater than 23. So you should take a perfect square which is nearer to 23, and it should also be less than 23. So such perfect square is 16, because after 16 it is 25. 25 is greater than 23, so you should take 16, which is less than 23. So 4 into 4 will give you 16. So just subtract this 16 from this 23. So you will get 7 as your number. So just take this second group down. So that is 04. Similarly, if you have more groups here, then you should not take third group here itself. You should take third group to next step. Here only 2 groups are there. So here I am ending with this. So now the new number which you have got is 704. Now just take the twice of 4. So what is twice of 4? Twice of 4 is 8, because 2 into 4 is 8. So now you should fill this particular position, and you should multiply with the same number here in quotient, so that you will get 704. So let us go on testing that. So 81 into 1, because I am putting 1 here and multiplying with that this particular number 81 with this particular number 1. So if you put 2, then you should multiply with 2. If you put 3 behind beside this 8, then you should multiply that with 3. So it is like 81 into 1, 82 into 2, 83 into 3. So I am verifying which number I should actually put in this particular position. So if I put 1, then 81 into 1 will be 81. So if I put 82, then 82 into 2 will be 164. So if I put 83 into 3, so 83 into 3 will be 249. So because 80 into 4 is 240, because 8 3s are 24. So 240 plus 9, so 249. So if I put 4, then 84 into 4 will be 4 4s are 16, 1 carry, 8 4s are 32 plus 1 33. So 336 is the answer for 84 into 4. That is also not actually approaching 704. So let us actually skip 2 numbers, because we want to go till 704. So like this, if you go on doing at a particular point, let's say like 87 into 7, let's say I am getting or not. 7 7s are 49, 8 7s are 56, 56 plus 4 60, 609. So here also I am not getting. So next I will be doing 88 into 8. So what is 88 into 8? 8 8s are 64, 6 carry, 8 8s are 64. 64 plus 6 is 70. That means when I put 8 in this particular position, I am getting 704. So you should go on doing this particular multiplication, and you should find which number you should actually put to get this particular number, whichever you have got here. So here if you put 8, you are getting 8 in the quotient as well. So 88 into 8 will be 704. So when you subtract this 704, you will get 0. That means this particular 2304 is actually a perfect square, because you are approaching 0 here. So whatever number you have got here in the quotient will be the square root, that is 48. So the square root of 2304 is 48. So next I will be solving 7th question in this particular first question. So in 7th question you have 5776. So here also you can use the same division method. So let us go on grouping this particular numbers. So 76 will be one group, 57 will be one group. So you should start from right hand side only. So which is the nearest perfect square for 57? 64 is actually nearest perfect square, but 64 is more than 57. So less than that is 7 square, that is 49, because 49 like 64 is nearer to 57, but 64 is more than 57. So 49 is actually less than 57, and it is also nearer, like nearest perfect square, which is less than 57. So square root of 49 is 7. So that means 7 into 7 will be 49. So when you subtract 49 from this 57, you will get 8. So just take this second group down. It will be 876. Now you should just multiply with 2. Like you should take the twice of 7 and put that number over here. What is 7 into 2? 7 into 2 is 14. And you should fill one place after the number which you are taking here. So when you actually put that particular number after those, after the number which you have got after twising the quotient, when you multiply that particular total number with the same number, you should get this 876. That means when you put 1, then you should multiply this with 1. So when you do 141 into 1, you will get 141. So this is not equal to 876. So now if you put 2 here, then it will be 142 into 2. So what is 142 into 2? 2 2s are 4. 4 2s are 8, 2 1s are 2. So 284. So this is also not working. So like this, if you go on doing, and if you put 5 here, so 145 into 5 will be 5 5s are 25, 2 carry, 5 4s are 20 plus 2 will be 22, 2 carry, 5 1s are 5 plus 2, 725. This is also not equal to 876. So this particular number is also not approaching 876. So let us try with next number. Let's take 6. So 146 into 6 will be, so whatever number you are taking after 14, you should multiply with that particular number itself. So this total number 146, like if you take 6 after 14, then it will be 146, and you should multiply that with 6 itself. So what is 146 into 6? So 6 6 are 36, 3 carry, 6 4s are 24, 24 plus 3 is 27, 2 carry, 6 ones are 6, 6 plus 2 is 8. So now you are actually getting 876. So that means when you put 6 here, you will get 876. That is 146 into 6 will be 876. So now we are getting 0. That means this particular number is perfect square. And the square root of that particular number is the quotient whatever you have got here. So that is 76. So square root of 5776 is 76. So that is the number which we have got here in the quotient. So square root of 5776 is 76. So let me solve the 11th problem which is there in this particular first problem. So in 11th problem you have 3136 as your number. So let us find perfect, like square root of this 3136, and we'll also get to know whether this 3136 is perfect square or not. So just go on grouping. 36 is one group, 31 is another group. Now which is the nearest perfect square for 31 which is less than 31? That is 25. Of course 36 is near to 31 which is also a perfect square, but 36 is more than 31. So you should take 25, because the next, like the lower perfect square after 36 is 25, which is less than 31 and which is nearer to 31. So nearest perfect square which is less than 31 is 25, and the square root of 25 is 5. So 5 into 5 is 25. So when you subtract 25 from this 31, you will be getting 6, and take this second group down, you will get 36. So 636. Take the twice of this particular 5, that will be 10. So you should put one position, like one number in the position. So that is actually one rule in this particular division method, where you should put one number and you should multiply that whole number with the same number which you are actually taking. So now if you put 1 there, then it will become 101, and you should multiply that with 1, because you are taking 1 here. So you are multiplying that with 1. So 101 into 1 will be 101, which is not equal to 636. So this number doesn't work here. So let us take the next number, that is 102 into 2. So 102 into 2 is 2 2s are 4, 2 zeros are 0, 2 1s are 2. So 204. That also doesn't work here. So like this, if you go on doing, like let us take 5. So 105 into 5 will be 5 5s are 25. 2 carry, 5 zeros are 0, 0 plus 2 is 2, so 5 ones are 5. You are getting 525. So next, this 525 is also not matching with 636. So let us try with 6. So 106 into 6. 6 6 are 36, 3 carry, so 6 zeros are 0, 0 plus 3 is 3, so 36 is that, 6 ones are 6. So you are getting 636. That is actually matching with this particular 636. So that means here you should actually put 6, and you should actually multiply this 106 with 6. So 106 into 6 will be 636, and you are actually getting 0 here in the remainder. That shows this 3136 is a perfect square, and square root of this 3136 is 56. So square root of 3136 is 56. So all these things you should write in a proper order, step by step, and then you should actually keep the answer. So if you actually directly do everything in the same step, and if you keep the answer, you will not get marks. You should actually step by step explain what and all things you are actually doing there. So then only you will get more marks, because if you have this particular question for 5 marks, then you should go on explaining each and every step which you are actually following to find this particular square root. So square root of 3136 is 56. So coming to the second question in this particular exercise, they are actually asking to tell how many digits will be there in the square roots of these particular perfect square numbers. So the first perfect square which they have given is 64. The second one is actually 144. Third one is actually 4489. Fourth one is actually 27,225. Fifth one is 390,625. So these are all perfect square numbers. You should tell how many digits will be there in that particular square root. Like if you take square root of this particular perfect square. So now if you take square root of 64, it is actually 8. So square root of 64 is 8. So 8 into 8 is 64. So how many digits are there in this particular 64? 1. So what is the square root of 144? Square root of 144 is 12. So how many digits are there in this particular square root? You have 2 digits. So 144 has 2 digits. Now if you want to find square root of 4489, you cannot do this because you don't know what is 4489. So now you should use division method and find the square root, and then you should actually count how many digits are there in square root. But in this question, they have particularly mentioned that you should not use any kind of calculation. So without doing calculation, just by seeing numbers, you should identify how many digits will be there in the square roots of these particular perfect square numbers. So there is a trick for this. So I'll just teach that. So if perfect square contains one or two numbers, like 2 digits in it, then its square root contains 1 digit. So if a perfect square contains 3 or 4 digits in it, then its square root contains 2 digits. So if a perfect square contains 5 or 6 digits, then its square root contains 3 digits. So if a perfect square contains 7 or 8 digits, then its square root will be containing 4 digits in it. So like this it will be going on. So here you should always remember 1 and second digit. Like if a perfect square has 1 digit, then its square root will also have 1 digit. And if a perfect square has 2 digits, then also its square root will be having 1 digit. So if a perfect square has 3 digits, then its square root will be having 2 digits. Even for 4 digit perfect square number also, you will have 2 digit as its square root. So this is one particular trick. So using this particular trick, you can easily visualize the number and you can easily tell how many digits will be there in the square root. So when you take the square root of that particular perfect square number, so you can easily tell these many digits are there. So now coming back to the question, here you can clearly see 2 digits are there in this particular first question. So here I have shown you that if a perfect square contains 1 or 2 digits in it, then its square root will be containing 1 digit. So here you have got 1 as your answer. So now coming to the second question, you have 144 as your number. So here perfect square is containing 3 digits. So a 3 digit containing perfect square and a 4 digit containing perfect square will be having 2 as its, that square root will be containing 2 digits in it. So answer for this second question will be 2. Answer for this third question will also be 2. So that means square root of this particular number will be containing 2 digits. Square root of this particular number will be containing 2 digits. Here fourth question and fifth question contains 5 digits and 6 digits respectively. That means here you can see this particular rule. If a perfect square is containing 5 digits in it or 6 digits in it, then its square root will be containing 3 digits in it. So the answer for this particular fourth question will be 3. That means square root contains 3 digits. And answer for this fifth question is also 3. That means square root contains 3 digits in it. Coming to the third question, here also you should actually find the square root of a particular numbers which have been given here. So similarly, what I have solved 3 problems in the first question out of 12 questions. So similarly, here in third question also you have 5 questions. Here also I will be solving 2 questions out of 5 questions. So remaining 3 questions you can solve. But one thing which is there in this particular third question is that they have given decimal numbers here. So in first question you just found out the square root of a whole number. So here in third question you are actually finding the square root of decimal numbers. So here 5 questions are there. I'll actually solve the first question and fifth question. So coming to the first question in this particular third question, you have 2.56 as your number. So similarly, we can use division method which we used in our first question for finding square root of decimals as well. So 2.56, which is the nearest perfect square for 2? 1. Because 1 into 1, like 1 square is 1. So 1 is actually less than 2 as well. So here 1 into 1 is 1. So if you subtract 1 from 2, you will get 1. You just take this. So you should actually group here. So 56 is one group, 2 is one group. So 1 is less than 2. That means the perfect square number 1 is less than 2. So 1 into 1, 1. So 2 minus 1 is 1. Take this 56 downside. So 156. So when you take a number which is there after decimal point, then you should put decimal in the quotient as well. So now it is 1 point. So now take the twice of this particular number. So 1 into 2. So what is 1 into 2? 1 into 2 is 2. So now you should put one more number after this particular number in this particular position, and you should multiply that with the same number here in quotient. So then you should actually get a number which is equal to 156. So now let me take 1 in this particular position. So I'll put 1 here. So it will become 21, and you should multiply this 21 with 1 because here you have taken 1. So you should multiply with 1. So 21 into 1 will be 21. So it is not equal to 156. So let us try with 2. So we'll take 2 here. So 22 into 2 will be 44. This is also not equal to 156. So next we'll take 23. So 23 into 3 will be 69. That is also not equal to 156. So like this if you go on doing. So let us take 26. So 6 6 are 36. 3 carry. 6 2s are 12. 12 plus 3, 15. So 156. So now we are getting a number equal to 156. That means in this particular position you should actually put 6, and in the quotient also you should put 6. So 26 into 6 will be 156. So when you subtract 156 from 156, you are getting 0. So the square root of 2.56 is 1.6. So the square root of 2.56 is equal to 1.6. Similarly, you can do second, third and fourth problem as well. I will show one more problem in this particular third question. That is fifth problem. So in fifth problem, you have 31.36. Here also you can use the same division method and find the square root of this 31.36. So here 36 will be one group, 31 will be one group. Nearest perfect square here for 31 is 36, but 36 is more than 31. So we should take 25. That is actually less than 31 and which is actually near to 31. So nearest perfect square is 25 and which is less than 31, and square root of 25 is 5. So 5 5 is a 25. So when you do 31 minus 25, you will actually get 6 here. Just take this second group downside. So it will become 636. So if you are taking number downside, which is there after this particular decimal point, you should put decimal point in the numerator as well. So now you should just take the twice of whatever you have in this particular quotient. So what is twice of 5 is 10, because 2 into 5 is 10. So after writing 10, you should put one more number and you should multiply this particular total number with the number which you are actually putting in this particular position here in quotient. So when you do that, you should actually get 636. So let me put 1 after this 10 and we will multiply with 1. Because you are taking 1, you are multiplying this 101 with 1. So 101 into 1 is 101. Now it is not equal to 636. So let us take 2. So if you take 2 after 10, you should actually take 2 in the quotient as well. So 102 into 2 will be 2 2s are 4, 2 zeros are 0, 2 1s are 2, 204. This is also not equal to 636. So like this, if you go on doing, if you put 105, so 105 into 5 will be 5 5s are 25, 2 carry, 5 zeros are 0 plus 2 will be 2. So 5 1s are 5. So you are getting 525. That is also not equal to 636. So if you take 106 into 6, then it will be 6 6 are 36. 6 zeros are 0. 0 plus 3 will be 3. So 6 1s are 6. So you are getting 636 when you do 106 into 6. So that is actually equal to this particular 636. So if you put 6 here, it will become 106 into 6 will be 636. So when you subtract this, you will get 0. So this whatever value you have in this quotient is the square root of this particular number. So that is 5.6. Square root of 31.36 is equal to 5.6. Coming to the fourth question, here also they have given 5 questions in this particular fourth question, and all these 5 questions are not perfect squares. They are non-perfect squares, where you have to find which number should be subtracted from that number to get perfect square. So here also you can go on following division method, which is actually closing to the final number which you are getting, and whatever remainder you will get, so that remainder you should actually subtract with the main number to get a perfect square. So after that you should find perfect square of the square root of that particular perfect square which you will be getting. So here in 5 questions I will be solving 2 questions. Similarly you can solve another 3 questions. So I will be solving second and third question in this particular fourth question. So coming to the second question in this fourth question, it is 1989. So here also you can use the same division method. The thing is, you will not get 0 at last, you will get remainder, because this particular number is not a perfect square. So here also you can make group. 89 will be one group, 19 will be one group. Nearest perfect square for 19 is 16, which is less than 19. So 4 into 4 will be 16. So you just subtract 16 from 19, it will be 3. Take this particular 89 to downside, so that will be 389. So take twice of this particular 4, so 4 into 2 is 8, and you should put one particular number here which should actually equal to 389. But here, since 1989 is not a perfect square number, you will not get, if you put any number starting from 1 to 9 in this particular position after 8, and if you multiply that with the same number here in quotient, like you got 0 in your previous cases because you are getting the number which was there. Like if 389 was there, then 389 was there. Like you can subtract that 389 and 389, you are getting 0. But here, since this is not a perfect square, you are not getting 389. So you should find nearest closing number for 389. So you'll go on finding that. So for this 8, we'll substitute 1 in this particular position. So the same division method which you have used to find square root of perfect square, the same division method you can use for non-perfect squares as well to find square root. So that is what I am doing here. So if you put 1 here, so 81 into 1. So if you are putting 1 in this particular position, then you should multiply with the same 1 here in the quotient as well. So here I have taken 1 and you are multiplying this complete number with 1. So 81 into 1 will be 81. Similarly, here 81 is very much far away for 389. So this is not approaching to 389. Let's take 82. So 82 into 2 will be 2 2s are 4, 2 8 2s are 16. So 164. This is also not near or equal to 389. So next, if you take 83, it will be 3 3s are 9, 8 3s are 24. That is also not nearing to 389. So next, if you take 84, so 84 into 4 will be 4 4s are 16, 1 carry, 8 4s are 32 plus 1, 33. So you are getting 336. So this is actually near to 389. So let us take 5 and check whether it is actually less than 389 or more than 389. So 85 into 5 will be 5 5s are 25, 2 carry, 8 5s are 40. 40 plus 2 will be 42. So you are getting 425, which you cannot take because 425 is actually greater than 389. You should take 84 into 4 because when you substituted 4, you are getting 336. When you substituted 5, that is the next number after 4, you are getting 425. That means you are not getting 389 here. That means this particular 1989 is not a perfect square. So you should take the number which is less than 389 and which is nearer to 389. So here 425 is not near. 336, like 425 is near to 389, but it is greater than 389. So less than 389, it is 336, which is actually near to this particular 389, because 249 and 336, if you compare, 336 is much more nearer to 389 and it is less than 389. So you should take this particular 84 into 4. So just put 4 here and 4 here. So 84 into 4 will be 336. So finally you are getting a remainder here. So 9 minus 6 is 3, 8 minus 3 is 5, 3 minus 3 is 0. So you are getting 53. So this 53 is your first answer, like answer for the first part of your question. That means this is the least number. So this is the least number which you should actually subtract to 1989 to get a perfect square. So when you actually subtract this 53 with 1989, you will get 1936. So this particular 1936 is a perfect square. So second part of the question tells that you should actually find the square root of this particular 1936. So you can follow the same method and you can actually easily find the square root. Here also you should group this. So 19 will be one group, 36 will be another group, 4 4s are 16, 3 will be remaining here. Take the twice of 4, that will be 8. So now you can take this 36 down. We already know that when we substitute 4 in this particular position, we will get 84 into 4. That is actually equal to 336. So 84 into 4 will be 336. So it will be 0. So the answer which you are getting is 44. That means square root of 1936 is 44. So here whatever perfect square you have got 1936. So if you take square root of that, you are getting 44. So the least number which you should actually subtract with this 1989 is 53. So that is the answer for the first part of the question. And you should actually find the square root of the perfect square which you will get when you subtract this particular number. So that is 1936. So 44 is the answer. Square root of 1936 is 44. So like this, using division method, you can actually find the square root, and also you can find whatever remainder is left out. If you subtract that, you will be getting the perfect square number, and you can actually find the square root of that particular perfect square number. Similarly, if you go to fifth question, here they are asking which number you should actually add to get that particular perfect square number. So here also you should follow the same method which you used for fourth question, but here whatever remainder you are getting, you should just add that particular remainder to the number and you should get the perfect square. So I will show one particular problem in this fifth question. So remaining you can actually solve. So let me solve the first question which is there in this fifth question, that is 525. So you should actually make group of this 525. So 25 will be one group, 5 will be one group. Nearest perfect square which is less than 5 is 4. So 2 2s are 4. So square root of 4 is 2. So 2 2s are 4. So 1 is there. Take this 25 downside. So you'll get 125. Take twice of 2. That is actually 2 into 2. So 2 into 2 is 4. And you should put one particular number here. And you should multiply this total number with the number which you have taken here in this particular quotient as well. So that time you should get 125 or a number which is actually nearer to 125. Here, since this 525 is not a perfect square, you should actually take that particular number which is greater than 125 and which is nearer to 125. And then you should actually add that number to 525. So let me explain that. So when you substitute 1 in this particular place, it will become 41. Then you should multiply this with 1, that will be 41. So 41 is not near to 125. So next is 42. So 42 into 2 will be 84. That is also not equal to 125. So next if you take 3, it will be 43 into 3. So what is 43 into 3? 3 3s are 9, 4 3s are 12. So you are getting 129. That means here you can see when you substituted 2, you got less than 125. If you substituted 3, you got more than 129. Here you should take this more number, because in previous case you are actually finding the lowest whole number, which if you subtract that particular number to the number which they have given, then you are getting perfect square. Here they are actually asking you should find the least whole number. If you add that particular least whole number to this 525, you should actually get the perfect square number. So that's why I will take the more, like the largest number than 125, which is nearer to 125. So here if I take 43 into 3, I am getting 129, which is near to this particular 125, and I'll substitute 3 over here. So 43 into 3 will be 129. So when you subtract 129 with 125, you'll get minus 4. So this minus shows that this 525 is minus 4 means this 525 is short from 4 number for the next perfect square. That means you should actually add this particular 4, because in previous case you got remainder as 53. So when you got remainder as 53, here it is plus 53, which you are actually subtracting. That means you are doing minus 53 with 1989. So here you should actually, you are getting minus 4. That means you should add this to 525. So that here minus represents that many numbers are short for 525 to reach the perfect square. So here 525 is short by 4 numbers. So if you add that 4, you'll get perfect square. So here minus is there. Should actually add that to this particular 525, because you have taken the greater number, not 84, the lesser number. Because if they are asking if you want to subtract, then you should take this particular number, that is 42 into 2. So if they are asking to add, then you should actually take 43 into 3. So when you do 43 into 3, you got 129 and you got minus 4 as your answer. That minus 4 minus represent that many numbers is short for 525. So that means that many numbers you should actually add. So 4 is the answer that you should actually add for this particular 525. So when you add that 4 to this 525, you will get 529. So now the perfect square which you have got is 529. So the number which you are actually adding for this 525 is 4. That means least number which is added. So least number added to 525 is 4. So the answer for first part of this question is 4. So coming to the second part of this question, when you add this 4 to this 525, you are getting a perfect square number, that is 529. You should find the square root of this particular 529. So if you find square root of 529, again you should make group of this. So it will be 4 into, it will be 2 into 2, which is actually 4. So 5 minus 4 is 1. Take this 29 downside, so it will become 129. So twice the 2 will be 4. So you take 4 here and you should put one number here, and we have already found out that when we put 3 here, it will become 43 into 3, that will be equal to 129, then you will get 0. That means the square root of 529 is 23. So the answer for second part of the question is 23. So you should actually add 4 to get a perfect square. And when you got a perfect square, if you find square root of that particular perfect square, you got 23 as your answer. So 4 and 23 are the answer for this first question in the fifth question. So like this you can solve for the remaining question. And always remember, you should take the highest number than the number which you are getting here. Here I have got 125 as the number, and here I am getting 129 and 84. So if they are asking to subtract, then you should take this 84. That means the previous number, the number which is less than this particular 125. So if they are asking add, then you should take 129. So depending upon the problem, you should actually decide which number you should actually take. So whatever number you are getting, if you are not getting equal to that, you should take either less or more number which is nearer. If you want to subtract, you should take the lesser number. If you want to add, then you should take the more number, and whatever remainder you are getting, you should add for that, or whatever remainder you are getting, you should subtract that. Coming to the sixth question in this particular exercise, they have given length of a side of a square. So this particular diagram, if it is a square, then its length and breadth will be equal. And they have actually given the area of this particular square. Area of this particular square is 4441 meter square. That means here you should actually find the length of this particular square, and square has length and breadth equal. So L into B will be L into L, because L is actually equal to B. So L square is the area of a particular square. So here they have given area, that is 441 meter square, and here they have given L square. So now you should actually find the length. So L square is 441 meter square. So when you bring this square to RHS, then it will become square root. So here square will be gone. So L square is equal to square root of 441 meter square. So here it will be, whenever you transform that to RHS, it will be plus or minus square root of 441. But you should use your logic and think that length cannot be negative because length will be having certain value which is a positive value. So here negative value cannot exist. So here instead of taking plus or minus, you can just take plus. But in certain cases you should take plus or minus both. So that means this particular L square has two solutions, that is plus and minus. But here since length is actually a positive value, so you should ignore negative term and you should just take plus. So plus 441 meter square. So if you take square root of 441 meter square, you will get the answer. To find square root of 441 square, you can use the division method. You can group this 41 and 4. So 2 2s are 4. So here you are getting 0. You just take 41 downside. So take the twice of this 2, that is 4. So here you should put one number which will actually equal to this particular 41. So if you put 1, then 41 into 1 will be 41 itself. So for the first number only you are getting 0. So that means in the quotient you are getting 21. So the square root of 441 is 21 and square root of meter square will be meter, because meter into meter is meter square. So when you take square root of meter square, you will be getting meter. So here square root of 441 meter square will be 21 meter. So the length of a particular square is 21 meter. In 7th question, they have given two questions. One is A and B. Here in both the questions, they have given right angle triangle and they have given value for two sides and we should actually find the third side. So if this particular triangle is a right angled triangle, then this particular triangle should be named as ABC and this particular B is actually 90 degree. So here in the A question, they have given AB is actually equal to 6 centimeter and BC is actually equal to 8 centimeter. They have actually asked to find what is AC. So according to Pythagoras theorem, so I can write here. So according to Pythagoras theorem, in a right angled triangle, so in Pythagoras theorem, if you have a right angled triangle, then the hypotenuse square will be equal to the sum of the square of adjacent sides. That means AC square will be equal to AB square plus BC square. So here AC square we should actually find out. So AC square is equal to AB square. AB is actually 6 centimeter square plus BC is actually 8 centimeter square. That means here you should actually take the square of 6 centimeter and 8 centimeter. So AC square is actually equal to 6 6 36 centimeter square plus 8 8s are 64 centimeter square. So I have taken square of individual terms. So here I have taken AB square and BC square. So that is 36 square and that is 6 square and 8 square, that is 36 plus 64. So what is 36? Here you can see this particular term is also having centimeter square and this particular term is also having centimeter square. So they have same SI unit. So you can directly add the numbers. So when they have same SI unit, you can add the numbers. So 36 plus 64 will be 100. So 100 centimeter square. So now you can bring this square to right hand side. It will become plus or minus. But here it is actually length. So it will be just plus. So plus square root of 100 centimeter square. So AC square will become AC. That is actually equal to square root of 100 centimeter square. So what is the square root of 100? It is 10. You can follow the division method and find the square root of 100. Or you can directly, you actually know that 10 into 10 is 100. So I am directly writing the square root of 100 is 10 and square root of centimeter square is centimeter. So the value of the hypotenuse of this particular right angle triangle, that is AC, is 10 centimeter. Similarly, in B question, they have given AC as 13 centimeter, BC as 5 centimeter. So coming to the B question, they have given AC value and they have given BC value. Here AC square is actually equal to AB square plus BC square. That means here they have given AC as 13 centimeter and BC as 5 centimeter. So here AC is 13 centimeter, BC is 5 centimeter. So here 13 centimeter square, like whole square, is equal to, they have given the value for BC, that is 5 centimeter square. So AB square we have to find out. We will just take this plus 5 centimeter square to LHS. So it will become 13 centimeter square, like whole square, minus 5 centimeter whole square, which is actually equal to AB square. So when you do this particular operation, so first you should actually solve this particular thing which is there inside bracket. That means you should get rid of this square, and then only you can actually perform the subtraction. So 13 into 13 is 169 centimeter square, minus 5 5 is 25 centimeter square. So here 25 also have centimeter square as its unit, 169 also have centimeter square as its unit. So they have same unit, so you can easily perform difference between 169 and 25. So 169 minus 25 is 144 centimeter square. So AB square will be there. So that shows AB square is actually equal to 144 centimeter square. Now you can take this square to right hand side. Then it will become AB is equal to plus or minus square root of 144 centimeter square. Here you should not take minus, because this is actually length of a particular side of a triangle, and length can be only in positive. So only it will be plus square root of 144 centimeter square. So what is square root of 144? 12. What is square root of centimeter square? It is centimeter. So the length of AB is 12 centimeters. So this is the answer for B question in this particular 7th question. Coming to the 8th question, here gardener wants to plant 1000 plants, and he should actually plant those plants in such a way that number of rows and number of columns should be equal. But 1000 is not a perfect square. So how many more plants he require to make to reach this 1000 to a perfect square, and that many plants he can actually easily plant in a particular land where rows and columns will be equal. So here, if you remember whatever I taught in 5th question, same logic you should actually apply here. So that means which is the least number you should actually add for this 1000 to make that 1000 a perfect square. So let us go on finding that. So we'll follow division method. So these two zeros and 10 will be one group. So the nearest perfect square is 9. So 3 into 3 will be 9. So 10 minus 9 is 1. You can take these zeros down. So down it will be zeros. So 100 will be there. Take twice of this 3. Twice of the 3 will be 6. 3 into 2 is 6. So if you put 1 in this particular position, then you should multiply this with 1, like 61 into 1. So 61 into 1 is actually 61. 62, if you put 2 here, then 62 into 2 will be 100, and 2 2s are 4, 6 2s are 12, 124. So here you cannot take 61 because they have asked to add the minimum number. So in the 5th question, if you refer there, which is the minimum number you should actually add for a number to make it a perfect square number. So at that particular time you should take the greater number than the number which is there. Like here 100 is there. So you should take greater number than 100, which is nearer to 100. So if you put 1 here, you are getting 61, which is less than 100. If you take 2 here, then you are getting 124, which is actually greater than 100 and which is nearer to 100. So 62, you can put 2 here. 62 into 2 is 124. So 24, here minus 24 will be there. So that means 24 more plants that particular gardener requires. That this negative symbol indicates that many plants are short for that 1000 plants to make a perfect square numbered plants. So that shows 1000 to become a perfect square, 24 is short. That means you should add the 24 to 1000. Here negative symbol indicates that many numbers are actually less for 1000 to make that 1000 perfect square. So that means you should actually add that 24. So 1000 plus 24 is actually equal to 1024. So he requires 24 more plants to that 1000 plants so that he can make equal number of rows and equal number of columns. So coming to the 9th question, here actually there 500 students are there, and if they are made to stand in equal number of rows and columns, then how many students will be left out? So here actually you should subtract those many students to get that perfect square numbered students, so that you can actually see how many students are left out. So in the 8th question you are actually adding, in this 9th question you are actually subtracting. So while subtracting you should take the nearer number which is less than that particular number. So I'll just solve that particular thing, you can understand while solving. So in this 500, 0, 0 will be one group, 5 will be one group. Nearest perfect square less than 5 is 4. So 2 2s are 4. So 5 minus 4 is 1. Take zeros downside. So it will be 100. So twice of 2 will be 4. So now you should put one number here, so that when you multiply that particular number over here, it should actually be less than 100, not more than 100, because here you should actually subtract those many students from this 500. So that will actually give you how many students are left out. So here if you take 1 here, then 41 into 1 will be 41. If you take 2, then 42 into 2 will be 84. If you take 3, 43 into 3 will be 129. 129 is more than 100, which you cannot take. 41 is less than 100, but 84 is also there, which is also less than 100, and which is actually nearer to 100. So here you should actually take 2. So 42 into 2 will be 84. That means 16 students will be left out. So 16 students will be left out of this 500. So here actually you should subtract 16 from this 500. That will give you 484. That means 484 students can stand in equal number of rows and columns, where 16 students will be left out who cannot be fit in that particular rows and columns. So this is all there in this particular video. By the end of this video, I am concluding squares and square roots chapter, which is the 5th chapter in this particular 8th standard mathematics. So after this, I will be teaching cubes and cube roots. So cubes and cube roots will not take much time, because if you understand this particular squares and square roots chapter properly, then solving problems which are there in cubes and cube roots will be very much easier. So please watch all 4 parts which I have uploaded in this particular YouTube channel related to squares and square roots for 8th standard mathematics. So if you want to learn more physics, chemistry and mathematics like this in my YouTube channel, then please do subscribe to my YouTube channel and stay tuned with my channel. Thank you.